Thank you. So as I told you, the title of my talk is basically focused on moons of the solar system planets. So I am aware that the moon is already being discussed with the participants of START program, and it has been already discussed that how solar system is formed. So, but apart from that, if you see the solar system in general, what do we see here is that there are 8 planets that are actually revolving around the sun. And among these 8 planets, we have the first 4 are called as the terrestrial planets, and then the next 4 are called as the Jovian planets. And within these Jovian planets, we have got gas giants, which are Jupiter and Saturn, and then there are ice giants, which are Uranus and Neptune. So what we are going to see today is that the solar system that we have, one of the solar system of the 500 solar systems in the Milky Way. So this solar system, our solar system, not only these planets are there, but there are so many moons which are there in the solar system. Specifically, if you see the Jovian planets, if you compare the Jovian planets and the terrestrial planets, you will find that there are so many moons in the Jovian planets, around the Jovian planets. With respect to terrestrial planets, we already know that Earth has a moon, and Mercury and Venus do not have a moon. Whereas if you see Mars, it has got 2 moons, Phobos and Deimos. But if you see the Jovian planets, starting from Jupiter to Neptune, multiple moons are there around these planetary bodies. And if we see them, totally if you try to count them, as per the latest information that we have in hand, we can see that there are nearly 293 moons, which are surrounding these planetary bodies. So it is very important for us to basically understand how come, first of all, these giant bodies have got so many moons. What are their context with each other, context of the moons with each other around the planetary body, and how these planetary bodies have, how these moons have evolved, how the surface of these moons look like. And let me tell you all that not all these moons have been explored in detail, but there have been some missions like Cassini, Voyager, these New Horizon. These are some of those missions which have made flyby missions around these moons. So whatever data we have in hand, we have from those flyby missions, and from that data we can analyze the geology, geomorphology, the subsurface, the atmosphere, the ionosphere of these moons. So when I say atmosphere and ionosphere, let me tell you that there are some moons or a moon in the solar system which has got an atmosphere, and that atmosphere is denser than the Earth atmosphere. I'm sure some of you may be already knowing that, but we will see that in detail in these slides. So, but before I get into my presentation, let me tell you all that all this data that are acquired by the flyby missions, they're all there in the web, and it is freely accessible. So anyone interested in exploring these moons can basically analyze, make use of this website, and they can analyze the data. Like you see here, all the moons of Saturn, majority of moons of Saturn for which we have flyby missions, all the moons of Jupiter, Neptune, and Uranus, the data sets are available. When I say data sets, it means images, spectroscopic information about the subsurface. All these are present. So anyone interested in this can make use of this particular feature present on web. And if you find any difficulty in downloading the data, you can contact me. That's why I've given my email ID below. So let us first start with the moons that are there, that we see around Jupiter. So if you see Jupiter, there are 4 moons. There are many moons actually, there are few moons which are actually in the inner orbit, which are very close to the Jupiter, but then there are many moons which are slightly further from the, or you can say, the outer orbit of Jupiter. And out of these moons, there are 4 very peculiar moons. They are called as Galilean moons because this has been observed and discovered by Galileo. So This is Io, Europa, Ganymede, and Callisto. So among these four moons, Io, the one which is always in news, it is actually one of the most curious, most curious object in the solar system. How do I say that? Why? Because it has got plenty of features that makes it different than any other moon that we have in the solar system, and we will see how it becomes so intriguing. And you see, these are the innermost moons. So what do you see here? I'm showing you the relative size comparison. So you can see Io is slightly bigger than Europa, but it is of course smaller than Ganymede and Callisto. But when you see the orbit of Jupiter and the moons that are surrounding it, not only that there are these Galilean moons, there are several other moons. We have just seen that how many moons are surrounding these Jovian planets. So you see so many orbits you can see. So, but these are very far away from these Galilean moons, and they are like very further, so they crisscross and all those, but they do not come closer. So when they do not come closer, although they may be having some gravitational pull from Jupiter, but as far as these Galilean moons are concerned, they are highly influenced by the gravitational influence of Jupiter itself. So when you see Io, it orbits very close to Jupiter at a distance of 350,000 kilometers above the Jupiter's cloud tops. So if it is so close, when you see Jupiter from the surface of Io, you will see that it is actually 39 times bigger than our own moon. So you can get a size comparison. The moon that we see in the sky, and if you are on the surface of Io, and if you look at Jupiter, it will be like 39 times bigger than our moon. So you can see how close it is to Jupiter. So you can now imagine that being close to such a huge planetary body, what type of effects may be ongoing on this Io. So one very peculiar thing that happens on Io is, the orbit. There is a term called as orbital resonance. So the orbit of Io is actually in sync with the two of the other moons. So you can see the relationship here. Ganymede, by the time Ganymede makes one orbit around Jupiter, Io makes 4 orbit around Jupiter. Whereas when you see Europa, by the time it makes one orbit, Io makes 2 orbit around Jupiter. And because of this, there is always a sort of gravitational influence on the moons. And because of the moons that are Ganymede and Europa, they exert gravitational influence on the Io. And that basically never allows it actually always enhances the eccentricity of Io. And when you see how it influenced altogether with the gravitational influence of Jupiter, you can see when the Io is actually revolving around Jupiter, it is undergoing it is under an experience of heavy gravitational influence from these moons and the Jupiter itself, and because of that, there is bulging of Io all around. So this bulging is so peculiar that you will see tides that are rising up to a height of 100 meters, and that is not very common. If you see on moon, it is very simple. The effect of tidal influence on our own moon, or because of on Earth, because of the moon, is very less. It is higher, slightly influenced. But when you see Io, it is highly influenced by the gravitational pull of Jupiter as well as the orbital resonance that is there with Europa and Ganymede. And as a result of that, what do we see? We see that there are volcanoes that are erupting on the surface of Io. And these eruptions have been captured by New Horizons in 2007. And I think this is the most intriguing thing that I have ever seen in planetary science, where one can see that the jets that are coming out from the plume, we can say plume, that is erupting from this particular place on the surface of Io, as well as you see that there are surfaces on the surface of Io which have changed over time. So you see, if you compare these two images taken by Galileo over the course of 3 months, you can see that there are regions which can reveal evidence of shifting of lava flow. You see, initially it was here, but then it enhanced and it is here. So you can make us understanding from here that Io is one of the planetary body or the moon, which is actually having an active volcanism. So having an active volcanism on a moon, isn't that very surprising? It is. It is very much surprising that we have, because these planetary bodies do not have tectonic plates. So despite of that, they are having such volcanic activities ongoing on the surface. We know very well that Venus has got volcanic activity, but then having volcanic activity on Io is really a surprising thing for me when we talk about the moons of the solar system. This is another example in which we can see plumes erupting from the surface of Io. You can see one example here and another one here. You can see the zoomed images of those plumes. You see that there are plumes that are erupting from the surface of the Io. So it is very important for us to understand how these plumes are forming, what exactly is the composition of the material, the gases that are ejected from the interior of the Io. Are they sulfur? Because sulfur is one of the most abundant gas that comes out when volcanism takes place. So is it that, or there are several other gases that are mixed? So it is something that needs detailed exploration, and I'm sure that in future we will have some missions where we will look in more detail at Io. But then scientists have also tried to explain how these volcanism may be erupting. So there are 4 different ways in which it can happen. These are 4 different basically models. So in one case, it says it could be a solid body dissipation in the deep mantle, where we have just like crust, mantle, and core, and then because of that, we have some molten pockets of magma in the interior, and that may be erupting. Then there is another concept that is solid body dissipation in the asthenosphere. So the asthenosphere is actually sitting over the molten mantle, and over time, due to the bulging, tidal bulging, the surface is fracturing and magma is oozing out. Then another concept says fluid body dissipation in the magma ocean. So just like the way we had magma ocean on Moon, it is assumed that maybe in the past there was a magma ocean on Io, and then that also is oozing out in form of fluid due to the tidal blocking, tidal influence that is there because of the Jupiter and the other moons. And then there is another one where they say that dissipation in a magmatic sponge, where below the crust of Io there are some pockets, some spongy pockets that make it look like as if little fracture is made, those sponge from those small pockets magma will ooze out, and those are called as magma sponge, which will ooze out if it gets a easier pathway to come out on the surface. So people have tried to explain these this intriguing volcanic phenomena that occurs on Io, but still it requires a lot of detailed investigation, for which we need more missions in the future. The next to Io is Europa. So Europa is another very intriguing moon of the solar system. So you can see the comparison between Europa and Moon. So Europa is actually not very small than our own moon, but slightly smaller. And it is the second and smallest of the 4 Galilean moons that we have. We have already seen the size comparison. Although it is second and smallest of the 4 Galilean moons, but if you see in the entire solar system, it is the 6th biggest moon in the entire solar system. So 6th biggest moon in the entire solar system, and it is so intriguing. If you see the surface of this particular moon, you will see that it is having a lot of linear features, and these linear features, although it may be not very wide, but they are several hundred kilometers long. So now you think how these fractures are forming. Are they fractures, or they are simply some sort of grooves, some sort of depression, some sort of collapsed units which are there on the surface of Europa? So it is very important for us to understand, and is that linked to something which is happening in the subsurface? And along with these linear features, we also see several circular marks. So what are these circular marks? Technically, these are called as lenticulae, but how these have formed? Are they simply corresponding to the material that is coming from the subsurface and pushing the crust, and then maybe they have formed jets in the past, and now what we see them as simple circular features, or they are simply the collapsed units? So it is very important for us to again understand that how these lenticules would have formed. And then there are a lot of chaotic features on the surface of Europa. You see, these are the chaotic features, and what we don't see on Europa is the craters. So you can see a couple of craters over here, but as such, if you see, you do not see those large craters, which makes the surface old. So you all know that whenever a surface forms on any planetary body, it will have no craters, and as it gets old, as it accumulates crater, basically it gets old. So you see in this example in particular, you don't see a lot of craters. So how it is like this? Why the surface does not have craters? Our moon has got lots of craters, but why this surface has not got craters? Or maybe the craters were there, they got erased due to some activity. So what is that activity? So these all features, make it very important for us to explore these moons. And what else we have seen with respect to Europa, that if you see the south pole of Europa, the presence of water vapor has been detected. And from where this water vapor can come out, most likely is that it could be from the subsurface. So the Hubble Space Telescope has observed evidence of water vapor, and it has been proposed that the subsurface of Europa might have some ocean, might hold water. And subsequently, later on also, you can see plume has been detected, and they have been detected around multiple years, 2014 as well as 2016. So modeling, there have been some modeling studies which outline a process for brine or salt enriched water in the subsurface of this particular moon, which moves around the moon, and eventually in some locations where there are fractures which connects with these salty water, it basically erupts in form of plumes. So that's why these moons are again having high significance when we look at the basic elements that are required for sustaining life. You need water, you need oxygen, you need organic compounds. So all these things have been basically, very promisingly, they have been observed on these moons. That is why these moons are very important. And based on these evidences, the structure of the Europa has been proposed, where it says that the lake has got an icy crust. It has a top is actually icy crust, and then it has got liquid water beneath that, and there is the rocky mantle. And what happens that because of this tidal effect, the core is actually always getting some influence, and it is always staying hot. And because of that, the water, the ice that is melting beneath is actually oozing out, and it is coming out of the surface in forms of jets or in forms of some other features that we see on the surface of Europa. So this is just one example. So here you see the water is actually oozing out of the fractures that are there on the surface. So if such a situation is there on Europa, can we think of having a sort of base on the surface of Europa where humans can survive, mankind can survive? So that's why these moons, they attract a lot of interest when we talk about exploring the possibility of having potential life on these moons other than Earth. So not only that, we are looking at the planets which are the terrestrial planets, but you see in the case of Jovian planets also, there are moons which have which hold evidence of having subsurface ocean, subsurface water. So can they be useful? Can they save us? Some people say that there can be some natural calamity in the future. So can we use these moons for safeguarding ourselves? So why? Because these moons have got those basic elements that are required for sustaining life, just like water. So among the other moons that are around Jupiter, Ganymede is actually another moon which is around which is next to Europa. And as we know that it is the largest moon that we know, and it is actually defined to be home to the largest ocean water. So if you compare the size of this Ganymede with Titan, it is actually slightly bigger than Titan, so 1.02 times that of Titan, and when you compare with Mercury, it is much larger than Mercury. So you see, Ganymede is bigger than Titan as well as bigger than Mercury. being a moon, it is bigger than a planet. So, but as I told you that being a very large moon, it has also got a large amount of water. So it is actually considered as the home to the largest ocean water in the solar system. But apart from all this, there is something else that makes Ganymede very unique, in the solar system. So we will see what is that. So just there is one another comparison where you can see with respect to the moons, how where does Ganymede stands with respect to having subsurface water. So it is the largest, uh, you know, having largest water body in the solar system in the subsurface. So it's of course special, but then it is also special because it is the only moon that has got the internal magnetosphere. And what do you see on the surface over here and here is basically the aurora that has been spotted on Ganymede. So the first question is that how can this particular moon can get magnetic field? And then the presence of aurora. So I am sure that you all know that auroras occur when the charged particles that are launched along the magnetic field collide with the particles in the atmosphere. So typically auroras form at that point of time. But how do we see it around Ganymede? You can see here it has been observed. Hubble space has seen presence of aurora. So there is a concept that tells that probably there is something that has to do with the presence of, because having aurora on Ganymede and having a stable aurora on Ganymede is actually something very peculiar. So it has been proposed that probably that there is a salty ocean, which basically makes this stability, that the aurora in the atmosphere of Ganymede is stable. It doesn't wobble a lot, although it is very close to Jupiter. It doesn't wobble a lot. Okay, but as such, if you see, it has got relatively older darker regions. The darker regions that you see are these ones, and then there are lighter regions. So the darker regions are old, larger craters are preserved in the darker regions, and younger regions are the lighter regions are the younger regions, which are dominated by grooves and ridges. And these grooves and ridges are again very high standing ridges. So then along with an old surface, we have a young surface, and that young surface is dominated by grooves and ridges. So how come we are seeing all these features on these moons? Something that is happening beneath that, or something that is happening externally on these moons that is actually modifying the surfaces of these moons, because you see very contrasting surface. One is very old and one is very young. So that type of combination is very intriguing for me. And based on these intriguing observations, the geological maps have been also prepared. So you see the detail of these maps, to what details they have been interpreted and identified and mapped. So this tells that the level of confidence that we have in terms of exploring the Galilean moons that we have in our solar system, at least the Io, Europa, and the Ganymede. So this boosts, this also boosts my confidence, to look at the datasets of these moons and then see how different are these morphological features, geological features with respect to the geological features that we see on Mars, Moon, Venus, Mercury. So because why these are very important, because this will tell us that already we know that there are some planetary bodies which have preserved old surfaces, but then here we see that there is an old surface as well as a young surface. So it is very important to understand how these different surfaces have formed over time. And this particular planet moon is one particular moon which you can analyze, you can study to get insights into the basically active processes that happen in these Jovian planets. Apart from Io, Europa, and Ganymede, there is another moon which is called as Callisto. So Callisto, if you see, has not been talked. People do not talk a lot about Callisto because they think that it has got nothing to do. It is a very boring surface. It is a very old surface. So why do we talk about Callisto? But being an old surface, an old surface has got a lot of significance. Why? Because you will not get old surfaces on Earth, or because Earth has got plate tectonics and Earth has got so many other phenomena that old surfaces are replenished on Earth. So if you want to study old surfaces, and it is considered as one of the very old surfaces, in the solar system, the surface is 4 billion year old. So getting a surface which is 4 billion year old will definitely tell us a lot of, information. Will provide a lot of information about the processes that occur during the formation of the solar system. That is the early epochs when the planetary bodies, the other planetary bodies of the solar system are formed. So all those secrets are basically, locked in on the surface of Callisto and the subsurface of Callisto. So if we can get access to the high resolution data of Callisto, one can make out how these different phenomena are there and how these older epoch events are there when the solar system formed. So you see, if you compare the diameter of Mercury and Callisto, again there is a very slight difference. It's just a few kilometers smaller than the Mercury. And then when we look at some of the high resolution pictures that we have of Callisto, one very important thing that we see here is that the surface is of course very highly cratered. But then when you see the rims of these craters, you see this is a crater, and you see the rim of the crater. When I say rim, it means that raised surface around the circular feature. So you see the raised surface is highly fractured or highly weathered or highly muted. So what is happening here? Why these features have broken apart? Yeah, I see a lot of gaps between them. Even you see majority of these circular features, they appear like very eroded, or you can say very like disturbed. So how that has happened? And then there are some which are still, we can see the boundary. So what is this happening on Callisto? So can we explain this? So one of the explanation is that probably there is subsurface CO2 ice, which is actually sublimating and causing these, erosion. So because of that sublimation, the ice is sublimating and it is creating void spaces. And due to that, the materials are collapsing and forming these eroded surfaces all around the craters. And that is varying in time. There are craters which are still intact, there are craters which are eroded. So over an old surface, which is 4 billion year old, we see differences in the events of, the activities that are happening on the surface of Callisto. So this is something very intriguing. So an old surface showing us signatures which are of that old time, as well as the event that is connected to the present day, that is the sublimation of CO2 ice. And then there are some other features also. You see this is a large crater, or you can say a basin, and then you see below also you see several fractures that are formed on the interior of the crater. So this could be a signature of possible sublimation of ice from the interior. And then there are very intriguing features where we see that lots of knobs kind of features are formed. These features are conical features. So again, the question is that how are these forming? Here as well as you see here, in both different, density is different in both the images. So can we have an explanation? We can try it. Maybe it is likely that these could be again some leftover, rims of the several craters that formed over time, but we cannot explain such dense population of this, because this type of thing we have not seen generally in the other planetary bodies that we often look at, like Moon and Mars. But you see here you see an intact crater, and then I see several eroded remnants, and then here the density is so high. So these things make, Callisto very intriguing. And as I have shown, you might be noticing that these things are not there in any of the other moons, any of the other Galilean moons. So that makes it very different. And you see, not only craters, there are large multi-link structures also. Like this is one example of a multi-link structure called as a Valhalla, which is there on the surface of Callisto. So that's why I'm asking this question, that will Jupiter's moons save us? So there is a notion, there is a science fiction that maybe these moons have got some basic ingredients or the essential ingredients that is required for sustaining life. So the question that I pose here is that will Jupiter's moon save us? Can we make use of the resources that are present in the subsurface of these moons and then make a sense whether we can, really stay there? Okay, so take that on a lighter note, but yes. Then coming to Saturn. So what do you see here is, this is the example of Triton. Triton comparing with the other moons of Saturn. So you see here, Triton is the largest moon of Saturn. And the moment I talk about Triton, I sort of get goosebumps because Titan is one of those moons which have been explored by instruments made by mankind. I am sure you may be knowing about the Cassini-Huygens probe that landed on Titan. So this is one of those moons which have been explored. And the two other aspects that makes it very unique is that Titan has got an atmosphere. Titan has got an atmosphere which is relatively denser than the atmosphere of Earth, and Titan is the only moon where we see this evidence of surface liquids. Whether it is water or some other form of liquid, that is still a question of debate. But there have been observations that there are surface liquids on the surface of Titan. So that's why Titan becomes very interesting in terms of exploring. First of all, exploring it and understanding how it evolved, and then exploring with respect to understanding signatures of past life. This is again a size comparison because this is very important when you are looking at the moons. You have to understand how big is the moon, where it is actually, the context is very important. So you can see Titan is actually slightly smaller than Ganymede and bigger than all other moons. But if you just keep Ganymede and Titan side by side, you may think that no, Titan is actually bigger. Ganymede is not the bigger one. But the truth is that Titan appears to be relatively big because of its thick atmosphere. The thick atmosphere is so thick that it goes up to several hundred kilometers, and that makes Titan relatively appear to look relatively bigger than Ganymede. So the vertical atmospheric structure is somewhat similar to what we see on Earth. So Earth as well as Triton, they both have got troposphere, there is stratosphere, there is mesosphere, and there is thermosphere. So if you see in particular the troposphere of Triton, you will see that at somewhere around 32-kilometer altitude from the surface, there is a presence of methane clouds. And then as we go further above, you will see the presence of tholin haze. So tholins are basically, it represents a wide variety of organic compounds which are expected to form by the solar ultraviolet or cosmic ray irradiation of simple carbon containing compounds. So when these are irradiated, carbon containing compounds can be carbon dioxide, it can be methane, it can be ethane. So when these are irradiated, tholin is formed. So it basically represents that particular class of compounds. So that is there at an altitude of somewhere around 120 to 140. And then as you go further above, you see a detached haze layer, which that haze layer is found at a altitude of 450 to 500 kilometer. And as we go further, we see that there is a event of particle production in the thermosphere of Titan. So this basically was concluded when Cassini made a closest approach, and it measured a large amount of heavy ions and particles. So that gave us a clue that there are some particle production phenomena happening in the thermosphere of Titan. And here what I show is the three different views of Titan taken in three different wavelengths. So the first image is actually a natural color composite, which is a combination of images taken by the three filters that are sensitive to red, green, and violet light. And here it shows what actually Titan may look like when we see with the naked eye. And the second one is the monochrome image, where we see Titan at a wavelength of 938 nanometers, which is a near infrared wavelength, and that allows to see the hazy atmosphere which is around Titan. And then the last one, which is the false color composite, here we see combination of two infrared images taken at wavelengths of 938 and 889 nanometers with a visible light image taken at 420 nanometers. And here what do we see? The green areas is actually those areas where we are able to see down to the surface. The red areas represents the areas which are high in the Titan stratosphere, where atmospheric methane is actually absorbing the sunlight, and the blue areas actually which we just seen as the detached haze layer. So these are the three different layers that we see very promisingly on the Titan using these three multiple wavelength images. And as I told you that there are evidence of surface liquids on the surface of Titan. So you see these are the radar images. So the areas that are smooth appear to be dark, and you see these smooth areas are there. It can be seen on the surface of Titan. And when we see the smooth areas in the colorful view, you can see that they have got very good drainage patterns. They have got very good drainage network. So these drainage networks are very common when we see on the drainage water body on Earth. So that's why it resembles that it could be none other than surface liquids. And interestingly, it has been observed that over time, when you see from 2007 to 2015, these surface liquid bodies have actually undergone change. You see this particular feature, it has actually evolved over time. You can see materials flowing away from this particular feature, and then again it is intact. So such changes have been also observed on the surface of Titan. So it is very important to see why these features are actually happening. And then some more observations where presence of vortices have been also observed, as well as the clouds have been observed. So all these phenomena have been observed with respect to exploring Titan. So all these phenomena makes evident that these moons are very significant in terms of understanding the intricacies of the solar system, and why they are showing such different characteristics. And one of the reasons you can think that we have seen till now Io, Europa, Ganymede, Callisto, and why they do not show evidence of surface liquids. So one of the reasons that we see evidence of surface liquids in case of Titan is that it is actually immersed in the magnetosphere of Saturn. So probably because of that, it is preserved from the radiation, that high energetic particles that are coming in the solar wind. So probably because of that, the atmosphere is intact and the features on the surface are preserved. It's not lost as in case of Mars. You know that Mars has a thin atmosphere. We don't see surface liquids on the surface of Mars. But here in this case, maybe because of since it is immersed into the magnetosphere, it is likely that it is protected, and that's why we see such particular features on the surface of Titan. The other very interesting moon is Enceladus. It is interesting, because when I saw some of these animations, I could notice that there are some jets that are coming out of these, moons from the surface of this moon, and these jets have been referred as icy particles, burst of icy particles from Enceladus. So, as I showed you Io, that volcanic eruption, now you see eruption, the plumes that are forming because of the jets of icy particles. So how can this happen on a moon? So what the interior of the moon is made up of? So I really, get very much fascinated when I see such types of features from around these moons. So definitely Mars, Moon, and even our Earth have got a lot of, intricacies, lot of secrets, lot of mysteries. But then you see these moons; they have more mysteries. So we should have more missions, more missions sent to these moons, and then see. We should immerse, just like how Cassini immersed into the plumes, and when it immersed into these plumes, it found basically that these are basically none other than water vapor plumes. And you see this extent of these jets. These jets are 40 times the size of Enceladus. So now you can think 40 times the size of Enceladus, that huge amount of jets, are being erupted from the surface of Enceladus. Probably these jets are erupted from these features, which are called as trigger stripes. So these are linear fractures, which may be, oozing out water by a process something like this, where it is said that because of the tidal effect, the core gets heated up and it basically melts the ice, and it basically oozes water from beneath, and that not only water as well as some organic compounds as well, and that all goes up, interacts with the icy crust, and then again goes out in form of these plumes. So along with these plumes and along with this detection of water vapor by the Webb telescope, phosphorus has been also discovered, in this Saturn's moon, Enceladus. So when I say phosphorus, it is the very essential building block for life, and that has been detected in Enceladus. So you see how relevant are these moons when we talk in terms of exploring the signatures of life, exploring this possibility of having a life or on these planetary bodies, maybe in the past or in the present. So that's why these moons I have been telling that they are very important for detailed exploration. Coming on to another moon, which is the Miranda, which is actually Uranus moon, and you see Miranda is actually located somewhere here if you compare with the other moons. So it is the closest one, and it is basically the innermost of Uranus' 5 round satellites. So Miranda, Ariel, Umbriel, Titania, and Oberon. It is the innermost one, and this is the only high resolution image we have, because it was only once that Voyager 2 probe could actually take up the close-up images of Miranda. But nevertheless, although once, but what we have seen that the surface is highly, it is like very complex surface. You can see a lot of features. You can see a 20-kilometer high scarp is there. How high is Olympus Mons? On Mars, it is 23-kilometer high, but that is a volcanic mountain. Here we see a scarp, which could be tectonic, and that is having a height of 20 kilometers. So then how it could have formed? It's very much intriguing that how can such a high standing scarp can form on such a moon. So that tells a lot about the active interior of these planetary bodies, and not only active, extensively active interior. Not only that, there have been some other tectonic evidences, like these are polygonal craters. So these polygonal craters, they typically form when there is a pre-existing fracture at place. So because of the presence of a pre-existing fracture, you may get these linear shapes, or they may end up forming these polygonal, circular feature may end up becoming polygonal. So such types of impact craters have been also seen on Miranda. And you see several other intriguing geological features are seen on the surface of Miranda. So the question that becomes important is again here is that how they could have formed. And you see another example here where I'm comparing the muted craters that are formed on Miranda, and how does it compare with the other moons. So these all the evidences which propels us to explore these moons in detail. And one another moon that is there is Triton, which is of Neptune, and particularly one particular special aspect of this particular moon is that orbit is retrograde. It means it doesn't rotate in the way the planetary body is revolving. So it is rotating in the other direction, opposite direction. Okay. So based on that, it is proposed that Triton could be a captured Kuiper belt object, because not all the moons have formed the way our moon has formed. Some are captured as well. So it is proposed that Triton could be a captured moon of Neptune. And the surface of Titan, if you see, it shows that it doesn't have a lot of craters. What does it signify? It signifies that it is capable of resurfacing itself. And if at all craters have formed, they might have get erased over time. So that ability to resurface is uncommon in the solar system. And it is again an indication, because these are icy moons, icy bodies. So it is an indication that the interior may be still warm. And if the interior is warm, as we have seen in the previous cases, water and all those fluids that are there in this interior may ooze out in form of jets or in form of plumes. So you can see how significant these moons are again. And there are other features as well. When I just told you about plumes, so you can see plumes have been, of course, observed, and geysers have been observed on the surface of this particular moon. And there have been several models that have been, used to explain how these geysers and all those plumes may be forming. I think I'll skip this, given that time is limited. But if you also see, there have been evidences for formation of cryovolcanism. You see, these are two volcanoes that are present. So these are cryovolcano. Cryo means ice. So they are having some sort of mud or mixture of mud and lava, those type of signature, or it can be relatively more mud than other features. So these features are also being spotted on this particular moon. And then coming to the one of the other moon, which is around this dwarf planet Pluto, which is this Charon. So Charon is very special again because if you look from an astronomer point of view, it is the Pluto and Charon system. They are actually called as binary system of planets, where, as in the previous cases, what we have seen that the moons are rotating around the planetary body, but in this case, it is not rotating around the, not only rotating around Pluto, but they actually make a binary system. So what happens that instead of Charon orbiting around the Pluto, Charon and Pluto orbit around a gravitational point between these two bodies. So there is a gravitational point between these two bodies, and there are several observations which has, New Horizon has also seen that it's not simply rotating around Pluto, but actually there is a gravitational point between these two bodies around which it rotates. This is just another example which signifies the binary system of planets. And you see the other moons that it has got 4 other moons: Hydra, Nix, Kerberos, and Styx. So these moons, they are also again not simply rotating, but you see they are rotating around the gravitational point between these two bodies. So you see how these moons are rotating. I have a video which can show you how somehow these are not running, but you can see how this particular Nix is actually rotating around the Pluto. And it is said that the sun might rise in the west on Nix and set in the east on one day, but in some other day the sun might rise in the east and set in the north. So types of intriguing aspects have been observed with respect to the other moons of Pluto than Charon. And of course the surfaces, again we don't have a full coverage, but still we see that there are canyons. These are very large canyons which are there on the surface of Charon. I had a video actually to show you how actually we can see the canyon, but the video is not running, unfortunately. And then the surface is having a very high elevation. You see, there are surfaces which are 6 kilometers high. So this signifies the presence of that deep canyon, because you have two high surfaces and in between there is a low surface. So this is the canyon that goes through. This is the canyon. So how can these canyons have formed? We know on Mars that there have been several geological episodes which led to the formation of valleys minors. But how do we see such canyons on Charon? So then, not only that, there are several tectonic features. Graben is there, ridges are there, scarps are there, grooves are there. These are tectonic landforms which are there. So is this moon tectonically active? Does it have plate tectonics? It's of course a very challenging thing to ask, but then how do we see these features? So I think again I had a video, but it's not running. So I'll quickly end by summarizing about Phobos and Deimos. So these are the 2 other moons of Mars. Along with Mars, these 2 moons are very significant. You see again, these are the this is basically the orbit of Phobos and Deimos. So Phobos, as you see, Phobos is relatively larger than Deimos, and Phobos is closer to Mars than Deimos. And our own Mangalyaan, Mars orbiter mission, has also observed Phobos. You see, this is a short animation showing the transit of Phobos over Venus, so over Mars. Since MOM had an elliptical orbit, it could capture this particular view. And then another example in which you see Phobos passing in front of Deimos. And you see the surface of Phobos, you can see grooves on the surface, and there are several craters in chain. So how come these grooves and this crater is called a Stickney crater? How this particular crater has formed, and why these grooves have formed? Are they related to the impact cratering process itself, or they have formed subsequently? You see, one side is having so much groove and one side is not having grooves. Why? Why is it so? So these are the questions that makes these moons very relevant. And here also I wanted to show you that transit of Deimos over Sun, and this was taken by one of the rovers that are there on the surface of Mars. So what we have learned today? So we have learned that there are among the Galilean moons that are there, we have seen that these Galilean moons are very significant when we talk in terms of exploring the presence of subsurface ocean, subsurface ice, and all these things on the neighboring, gas giant, the Jovian planets. And not only that, our moon holds several secrets, several mysteries. These moons that are there around the Jovian planets, they also hold a lot of, mysteries. They have got, some of the moons have got dense atmosphere, some have got internal magnetosphere where auroras have been spotted. Presence of liquid has been seen on the surface. Then we have seen some of the moons that are volcanically active, and we have seen some of the moons which are very old, 4 billion-year-old surfaces are there. And then along with that, we also see moons that has got both old and young surfaces. And then we also see moons which are not old, the surfaces are very young. So all these combinations today we have seen, and I'm sure that the attendees of today's lecture will definitely go and look at some of these moons. Using the I have already shown you how we can download the datasets. So I invite you all to get into this domain of planetary science and look at these different datasets of these different moons and try to see how these moons have evolved, how the surfaces have evolved. Okay, I think I'll end here. Thank you very much for giving this opportunity.